on number 12, we're to write a function of minimum degree in standard form with real coefficients, including the zeros listed. And I've taken the liberty of jotting down the implied second complex zero here because we were given negative 2 and 1 plus 2i, but you've always got to remember to include the conjugate as the other zero that comes along with the first complex zero they give you. So our first factor will be x plus 2. Our second factor will be x minus 1 plus 2i in parentheses. And then our third factor will be x minus 1 minus 2i in parentheses. And then we have to multiply it together to get it in standard form. And I always recommend that you start by multiplying the two factors with the most in common, because that's just easier to put those together. And so we have these two factors that involve a complex number, or a complex zero. So let's put those together first. And x times x is x squared. And then our outer product is minus 1 minus 2i x. Our inner product is minus 1 plus 2i x. And then the product of the last is minus times minus gives me plus 1 plus 2i times 1 minus 2i. And then we come back and clean up that second factor before we involve the x plus 2 that we're still holding over here to the left. And then we've got first our x squared, and then we've got a minus x distributing to the 1 minus 2i, which gives us minus x plus 2ix. And then on this next one we have minus x distributing to 1 plus 2i, so we get minus x and then minus 2ix. And then we're going to come down here and get these two guys together, and again we're using a plus b times a minus b to deal with these each time. It's much faster. And 1 times 1, or 1 squared, minus 2i squared would be 4, and then I squared is negative 1, so that's really plus 4. We come back, let me put a parenthesis on that. We come back and get that all cleaned up before we involve the the x plus 2 up here at the front. And we've got for our second factor x squared, then we have a minus x and a minus x is minus 2x. And then this plus 2ix and the minus 2ix take each other out. And at the end, you have 1 plus 4, which gives us plus 5. And then we're going to multiply these two together by first distributing the x, which gives us x cubed minus 2x squared plus 5x. And then we distribute the 2. And then that's plus 2x squared, and then minus 4x, and then plus 10. And writing it this way with this vertical alignment, you just pull your like terms down. We've got an x cubed. The x squareds take each other out. 5x minus 4x is plus x, and then the 10 has nothing to add to it, so that's our constant. And that is our standard form polynomial for number 12. On number 14, we are given a pair of zeros with their multiplicities, and then we are to write a polynomial function of minimum degree in standard form with real coefficients that match this description. So here we go. F of x equals, if negative 1 is our 0, our factor is x plus 1, multiplicity 3 just says that's cubed. So we put a little 3 exponent there. And then our 0 is 3, so that's x minus 3. Multiplicity 1 means I don't need an exponent on that one. Well, then we've got to write it in standard form, means we've got to expand it. So let's start with that x plus 1 cubed, and we'll have an x plus 1 we pull out to the side, and then we are going to take advantage of the fact that we know our patterns here. We're going to do a plus b squared equals a squared plus 2ab plus b squared. If you ever wondered why your teachers back in Algebra 1 tried to get you to know that pattern, hopefully that will become clear now. So when we multiply x plus 1 squared, we get x squared plus 2x plus 1, and we've still got to bring in that x minus 3. And we can multiply the x plus 1 and the x minus 3, and we can do x squared, and our outer product would be minus 3, our inner product would be plus 1x, so that gives us minus 2x, and then the 1 and the minus 3 multiply to give us minus 3, that we'll multiply by the trinomial we created using the pattern, and we get x to the fourth plus, because we're distributing the x squared onto the second trinomial, 2x cubed plus x squared. Now we're going to distribute the 2x, or minus 2x. Minus 2x would give us minus 2x cubed and minus 4x squared, and then minus 2x. And then we would distribute the minus 3 to get minus 3x squared, and then minus 6x, and then minus 3. And when we combine these terms for our final answer, we will get x to the fourth. These two take each other out, and then I have 1x squared minus 4x squared would be minus 3x squared, gives me minus 6x squared combined with the other minus 3x squared. And then when I combine my minus 2x and my minus 6x, I get minus 8x, and then minus 3 is my constant, and there is my polynomial that fits that description. Now let's go to number 16. And 16 is going to be a little more complicated because of the fact that we have a complex number. So that means that we are going to have to include a second complex zero that they didn't give us because the conjugate, remember the conjugate comes for free. So that'll be our other complex zero there. So we start with f of x equals x plus 1, and that's squared because our multiplicity is 2. And then 2 minus I has a multiplicity of 1. And since we want minimum degree, we will use the same multiplicity for our other 0, the conjugate that we brought in. So that's x minus negative 2 plus I. And now we're ready to start expanding. Again, I take care of the like stuff together. So x plus 1 squared, again using that pattern, is x squared plus 2x plus 1. And then we'll FOIL this pair and get x squared, and then our outer product will be minus negative 2 plus I x. Our inner product will be minus negative 2 minus I x. And then our final part of that multiplication is a negative times a negative gives us a positive. Negative 2 minus I times negative 2 plus I closes out our expansion of the two complex factors. So this step we're just cleaning up. Excuse me. That factor's ready to go, so we're going to go over here and get this other one straight. X squared comes on down, and then again we're distributing a minus x to a negative 2 first, makes that a plus 2x. And then minus x on I is minus ix. Minus x on negative 2 is plus 2x. Minus x on negative I is plus ix. And then we come down here to the end and look at our two complex numbers, which nicely fit into the a plus b, a minus b pattern. And so our a squared, our a here is negative 2, squared is 4, and our negative I times our positive I give us minus I squared, which is minus negative 1, so that's really plus 1. Not quite through with the cleanup process of that second factor, so we'll take care of that on this step. X squared comes into our answer, and we've got a 2x and a 2x gives us a 4x, and then we have minus ix plus ix and plus 5. I hope you guys are seeing the pattern here, how we keep having the missing ix terms, they get taken out there on that step, because that should happen every time. And then we just distribute from good old Algebra 1 days. X squared distributes across to the second trinomial and gives us x to the 4th plus 4x cubed plus 5x squared. And on the next line down, we're going to distribute 2x, and 2x times x squared is plus 2x cubed. 2x times 4x is plus 8x squared, and 2x times 5 is plus 10x. Then we distribute the 1, and we like distributing 1 because that means we're just going to get what's there. So you just copy that straight on over, and now we'll bring all this into our final answer. Got room to squeeze this down at the bottom of the screen. We get x to the 4th. Combining our cubic terms gives us plus 6x cubed, and then combining our x squared terms gives us plus 14x squared. And then add our x terms, we get 14x, and tack on our constant, which is 5, and that's our final answer for number 16.